The sky, back to the sky.
Back to the sky.
Tomorrow is one of the four significant dates in the annual calendar as far as astronomers are concerned. The equinox, when the sun will cross the equator going from north to south. And tomorrow then, if you're on the equator, the sun will be exactly overhead at your local noon. And equinox means not equal night, but it's short for that, if you like. It actually means the time when, in theory, it's equal day and equal night, nox being the night bit. The day bit of it is left out, but it's not as simple as that. Sunrise and sunset are not defined as when the center of the sun is on the horizon. It's when the upper edge, or the upper limb, as astronomers call it, of the sun is on the horizon. And that means that a day is actually slightly longer. So if you imagine when the sun is rising in the east, as soon as the very first top bit of the sun appears above the horizon, that's defined as sunrise. And then at the end of the day, as it's setting, it's not sunset whenever the lower edge of the sun touches the horizon. Sunset is defined as when the upper edge of the sun finally disappears below the true theoretical horizon. So that adds actually quite a few minutes, depends on where you are, other factors involved, quite a few minutes to the length of the day. There's also another factor called refraction. The lower something is down in the skies, we see it here from Earth, the greater the amount of the Earth's atmosphere that its light has to pass through to reach us. And this takes us back to the gravitational effect, lensing effect. This time it's optical refraction rather than gravitational refraction. And that means that when you look at the sun as it's near the horizon, it actually appears higher up than it really is. In fact, at the moment when the sun has completely appeared above the horizon as we see it, actually it is still below the horizon. If we had no atmosphere, that you would not be seeing the sun there at all. So when you add those two effects together, actually make a day, and this is specifically for here, UK, Ireland, on the equinox tomorrow, the day will not be exactly 12 hours long, it will be 12 hours, 11 minutes long, and the night of the following night, tomorrow night, will actually be 11 hours, 49 minutes long. So that means, in effect, even though it's the equinox, the day tomorrow will be 20 minutes longer than the night. And the same thing, of course, happens with the spring equinox. But it's one of those little quirks in astronomy where things seem simple, but when you look into it in a bit more detail, they're just not so simple. But it's very educational. For example, the refraction effect is a very significant effect. If you're an astronomer and you're looking for the position of something actually in the sky, it's not until it gets up above about 40 degrees, 45 degrees above the horizon that the effect of refraction becomes more or less negligible. So that's all factored into your computer programs and so on. Whenever you're looking for an object in the sky, the computer allows for the amount of refraction that's there. But it also tells us, of course, about the seasons, the fact that the tilt of the Earth's equator to the ecliptic, the path of the sun around the sky as we see it from Earth, is tilted at 23.5 degrees. Whenever the North Pole of the Earth is tilted towards the sun, that's our summer. Whenever the South Pole is tilted towards the sun, that's their summer and our winter. So we take it for granted. The equinox maybe doesn't get quite as much attention as the summer and winter solstices, but very educational. But it's not just a matter of equal day and equal night. Over to you, Nick.
The way I know about this, for anyone who knows me, knows I live quite near to Avebury, which is one of the big stone circles. So international listeners and viewers may have heard of Stonehenge. Stonehenge is like this world famous monolith, a set of megaliths around in a circle with lintels over the top. About 1 mile away from my house is another one called Avebury, which is even larger than Stonehenge, but doesn't have the famous kind of cross lintels as it were. And every year, regular as clockwork, 4 times a year. So winter equinox, winter solstice, summer solstice, and then the 2 equinoxes, we get thousands and thousands of people descending on the area and making parking a real problem. But yes, it's a good way to remind yourself that these things are happening. It's a great, as I said, it's one of those great fun things if you've got kids in particular, you're getting them into astronomy, and you think about in the era before the telescope, when the ancient peoples were just looking up at the sky and making notes of the precession of the planets and looking at where the planets were, and these strange objects, comets appearing in the sky and seen as harbingers of doom. And then, working out that if the sun rose at this point, they'd be able to put, marker stones in to show them when they could plant their crops, or they could do a specific thing, or would help them understand the Nile, for example, ancient Egypt, and when the Nile was going to flood. All of these things were based upon astronomical observations and calculations. So it may seem like a really trivial thing, but it's a beautiful example of not only orbital dynamics and some of Newton's laws in terms of gravity, etc., but it's just a wonderful way of kind of explaining and showing the motion of our pale blue dot around the sun. It sounds really simple and really trivial, but it isn't. It's a nice one, I'd say.